Hello, everyone. We still have a few people logging in, so we're going to give them a minute or so before we start. Alrighty. Hello, everyone, and welcome to this webinar, Optimizing an LLM Chatbot with a Knowledge Graph. My name is Maya Natarajan, and I'm VP of Product Marketing at Memgraph. I'm super excited to kick off this webinar. We have special guests William Firth, Senior Data Scientist, and Zhao, Data Scientist from Microchip Technology, who have used LLMs, LangChain, and Memgraph to build a contextual chatbot. Before we get started, let me share some housekeeping rules. Today's webinar is being recorded. We will share a link with you after the event is complete. We also invite your comments and questions. Please note that there's a Q&A box on the right-hand side of your screen. If you have a question at any point in time, just type it in there and we'll get to those at the end of the event. Alrighty, let's get started. What I'm going to do right now is set the stage as to how knowledge graphs play a key role in the Gen AI world, and then hand it over to William to talk about how he has used a combination of LLMs and a knowledge graph to build a contextual chatbot. The whole world is abuzz with Gen AI, and rightfully so. Gen AI can generate content such as text, images, and videos at the back of a simple natural language prompt. It's that powerful. However, there are a lot of potential risks stemming from the probabilistic nature of these models. The first risk is that Gen AI hallucinates. It generates false information that may sound plausible, but such information is not based on input data or reality. Secondly, Gen AI lacks transparency and explainability due to the black box nature of AI models. And last but not least, Gen AI quickly becomes outdated. This is because the responses are based on AI models that are trained on data that they were initially exposed to. And obviously that data becomes outdated at some point in time. So how can one take advantage of Gen AI? Enter knowledge graphs. First of all, what is a knowledge graph? According to Gartner, a knowledge graph is a machine-readable data structure that describes the link between heterogeneous data via a network of nodes and relationships. The key words here are nodes and relationships. So what does a knowledge graph do? A knowledge graph captures domain-specific information and so provides real-world context. It is this real-world context that grounds Gen AI and prevents it from hallucinating. How powerful is this context? We see it in action when we use large language models or LLMs. An LLM is basically a machine learning model that understands and generates natural language text. Now, when used alone, an LLM takes a user prompt and creates a response based on data it was trained on, or basically what it already knows. LLMs excel at pattern recognition and statistical analysis, but they lack an understanding of the context of the data they process. Okay, so how can we improve these LLM responses? By using a technique called Retrieval Augmented Generation, or RAG. What RAG does is that it enriches LLMs. Now, RAG basically consists of two parts: the retrieval phase, shown on top with the green arrows, and the content generation phase, shown by arrows in purple. In the retrieval phase, algorithms search for and retrieve information relevant to the prompt. This information is then enriched by data from external sources, such as websites or databases. Now, this could be a relational database, a NoSQL database, a vector database, or of course, our favorite, a graph database. In the generative phase, the LLM uses the augmented prompt and its internal training data to create a response to the user in that instance. So you can see how the knowledge graph in this case has enriched the LLM for a more contextual response. Now let's just see this in action instead of you're just taking my word for it. I'm going to use the Game of Thrones to showcase this. Who doesn't like Game of Thrones, right? It's got kings, queens, knights, renegades, honest men, liars, and many, many more, all playing a game to get control. As you can tell, I'm a big fan. Now, why Game of Thrones is perfect is because there are a lot of complex relationships amongst the various characters in multiple ways. So it gives us the perfect opportunity to test LLMs alone and then LLMs with RAG. For RAG, we're going to use a graph database, or in other words, a knowledge graph. Okay, Let's look at this prompt. Who has the most kills? It's a fairly simple prompt, so the LLM alone should give us the correct answer, right? Let's take a look. The LLM alone says it's Arya Stark and quite confidently points out that she is skilled with the sword and has taken down many an enemy throughout the series. Now let's see what happens when we add a knowledge graph to the mix. Before we look at the response, let me quickly walk you through the steps of how the prompt is being processed. We have the natural language prompt, or query in this case, and it is who has the most kills. This natural language prompt is converted to a cipher statement, as you can see here, just FYI. The LLM is doing this based on a knowledge graph schema. The query then gets executed. This is then passed through the LLM again in the generative phase, and then you get a response back in natural language. Now, with the knowledge graph to enrich the LLM, we see that the response is Daenerys Targaryen with the most number of kills. To be exact, she has 1,044 kills. While this is a relatively simple query, we actually have to traverse one hop because we have to look for killed characters and then figure out the sum. These are what we call recursive queries, queries that require you to go 1, 2, 3, or more hops in depth. And this is exactly where graphs shine. Hops are second nature to them, whereas LLMs struggle, as we saw in this example, because it does not have the context that relationships provide. Now, just as a quick side point here, I want to add that most graph databases are limited to 6 hops at the most, except for Memgraph. Memgraph can easily deliver 10 plus hops, and this is an advantage where there are gnarly connections, as we see in fraud or ultimate beneficial owner use cases. All right, let me finish here with one last slide before I hand off to William, and that is how, or rather, what you need to create a contextual chatbot with Memgraph. Not surprisingly, we'll need an LLM. We can use open source models like ChatGPT or Llama. And of course, if you're an organization like Microchip Technology, you'll want to use your own private LLM. You'll need to integrate the LLM with a Memgraph via LangChain so that you can query the graph database in natural language. We have a tool called GraphChat that does this. It's an integration between Memgraph Lab, our visual tool. So Memgraph Lab's backend written in Node.js with the graph cipher QA chain from LangChain, from the LangChain library. And it converts natural language to cipher in the retrieval phase and cipher to natural language in the generation phase. The answer is then passed to a chatbot with links to its sources. All right, having given you this little primer on knowledge graphs, GenAI, LLMs, and RAG, let me hand it over to William so that he can talk about the good stuff, the implementation of a real-world contextual chatbot using Memgraph and at Microchip Technology. William?
Hey, everybody. Let me share my screen here just a moment.
While William is getting ready, let me remind everyone that there's a poll that we'd like you to take. In this poll, we'd like to know where you are in your graph journey. Please respond, as this will help us tailor these webinars for you. All right, William, go ahead.
So, hi, everybody. I'm really excited to be here today to talk to you about graphs and LLMs. But I don't actually want to focus too much on the how. Maya went over a pretty good job going over the how it works. And we'll talk a little bit about that from a high level. But what I really want to talk about today and what I'm really excited about is going through the hurdles that we've had to face, going from using something that's just a prototype or an example data set and turning it into a real business solution. So specifically, I want to talk about how you decide what type of use case this kind of solution is for. I want to talk about data and specifically data privacy, and then we'll talk a little bit about scale. But first, just so we're all on the same page, I want to talk about what we mean when we say LLMs and graph database retrieval. And the best way I know to do that is to actually go through how we would do this manually. So if you wanted to use ChatGPT to help you write a cipher query because you have a database and there's information in that Memgraph, that graph database, what would you do? Well, you'd have a question and you'd probably open up ChatGPT and you'd write something like, hey, can you write me a cipher query that answers this question? and it would probably write you a Cypher query. But if you go and you copy and paste that and put it into Memgraph, it most likely is not going to work. And you might scratch your head and start to think, well, why isn't this working? Well, it's probably because the LLM doesn't have the information about your database. It doesn't know what nodes, it doesn't know what edges, it doesn't know what attributes you have access to. So it just kind of made something up. So you'll go back to ChatGPT and you'll say, hey, write me a Cypher query that'll answer this question using these nodes, these edges, and these attributes. And that's where things start to get really interesting, because it can probably get you something that'll work. So you'll copy that Cypher query, you'll go into your Memgraph database, you'll run that query, and you'll get results. And for the purpose of this kind of thought experiment, let's assume we're not trying to return a graph. We're trying to return the data, the information, the attributes about it. So you can copy that data and you'll say, well, this data is, I know my answer's in this data somewhere, but it's not easy to read. It's not natural language. So I'm going to take it and I'm going to go back to my LLM and I'm going to paste that in there. I'm going to paste in my original question. I'm going to say, hey, ChatGPT, answer this question using the context, using this data that I'm providing. And then at that point, the LLM will be able to answer your question. It'll summarize those results and answer them in terms of your question, and then I'll go back to the user. So that's all we're really doing here. Just the idea with using something like LangChain is to chain all these pieces together, all these different language actions together, hence the name LangChain, and abstract them all away so that all the user sees is they input a question and they get a response back. And there's actually, LangChain can interact with a lot of different data sources, but there's a specific function called the Graph Cypher QA chain that is built exactly to do this. So all you pass in are the API keys to your LLM, the connection to your graph database, a couple pre-written prompts to do the Cypher translation and to summarize the results. And then you can just call that function and put your question in, and it'll jump through all these steps and get you back an answer. So where is this actually useful though, right? Like Maya, we're great friends, but like Game of Thrones, like that doesn't do anything for me. What's the return on investment there? So from a business case, I don't really see how that helps me. And I was really skeptical of this. I thought it was, kind of gimmicky. It works, right? And it works pretty well, but it's slow. You're going through multiple LLM calls. You're going through a database call. I can do this a lot faster, right? I've been working with graphs for years. So I know how to write Cypher. I can just go directly in the database and I can type out my Cypher query in a matter of seconds and get the results and interpret them myself. Why do I need this slow solution? Well, I still kind of stand by that. It's the use case is not really for me as a seasoned developer, right? The use case is for bridging that gap between the consumers of the data and the data itself. Because often the people making business decisions, they're not the ones with their hands in the data, right? The people that have their hands in the data are the analysts, the data scientists, the people that are building the dashboards, building the models. But the people making decisions, the business decisions, are just consuming that information. And there's often a disconnect there. And there's often a middleman. And so being able to connect the business decision maker closer to the data, we can make great strides in efficiencies and performance. So what's an actual use case of what I'm talking about there? Where does that gap exist in the real world? Well, in our case, we have a customer service team. And that customer service team will get questions from customers or upper management of something like, why is this sales order late, right? Why is this customer sales order late? And that's a really important question, right? And it's a really hot question. It needs to be answered quickly because you don't want to leave our customer hanging and not tell them why their order's late or what they're doing about it, right? So we need information quickly. But the customer service team, they don't have that information on the top of their heads. They're not the ones in the factories. They're not the ones in the fabs dealing with the production issues or the supplier delays for why something is late. So they have to go to a middleman, another party, and ask the planning team for that information on the customer order shipping status. Well, that can take a while, right? Because we're a big company. We work in multiple time zones. We work all around the world. So, you might get a question in from a customer and send that off to the planner for an explanation, but the planner might already be home, right? Because they're ahead a couple hours, or they might not be into work yet, or they might be out at lunch, or they might just be really busy and not be able to get to it. So you have these long delays when you have this separation of, the need for the data and the person that has the data. And so we have these delays, or we have, noise in the interpretation of the data we're getting back. Maybe the planning team didn't understand the question, and so, they leave off something. So the more we can get our customer service team closer to the data, the better. And it just so happens, that this information that the customer service team doesn't just live in the planning team's head. This information actually is available and stored in a graph database that we have on-prem at Microchip. So the idea is, can we build a customer service chatbot called Workspace, because Workspace is the name of the database, that can pull out the middleman, can pull out the planning team, and give the customer service team direct access to that database and the information inside it 24/7 and on demand. So this is hugely beneficial to the customer service team because they get information on demand. It's hugely beneficial to the customer because the customer is not waiting on us, the customer service agents, to get back to them with, why it's late and what we're doing about it. And it's beneficial to the planning team because the planning team has a whole other, full-time job. They're trying to plan our work orders in factories, and they don't want to have to be stopping to answer these questions. So it's beneficial to every party here if we can pull this off. And we did pull it off. So this is an example of what the interface looks like. This is a Streamlit app. And on the right-hand side, you can actually see the interaction between the human and the LLM. So that's the part where you see, here's the question, and then it gets abstracted away, and you just see the answer. So we can ask the question like, why was the sales order late? And we get back, hey, the sales order was late due to adjustments to business conditions, blah, 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 blah. We can ask follow-up questions. Hey, are there any work plans in place to improve the ship date? And it can answer that in natural language. What's going on the left-hand side is a little insight into what's going on in the background. So you can see we ask a question, why is the sales order late? That gets translated into the generated Cipher query that you see at the top left-hand of your screen. That Cipher query gets run through the database. The database results are that full context below the Cipher query. And you can notice, that's a little bit hard to read. It's not natural language. So we pass that back into the LLM and ask it to summarize it and answer it in terms of the original question. And then we finally get back out the response from the LLM. So this is what it kind of looks like. So that's the first hurdle, is knowing where this makes sense to use it, right? And what use cases it's helpful for from a return on investment standpoint. But if you're very observant, you might have probably noticed, the second hurdle or seen some problems in the graphic I was showing you, right? And that's that we probably don't want to be sending our entire database schema into ChatGPT, the public API. We probably don't also want to be passing in the entire history of our conversation, which includes sales order numbers, the entire schema, plus the database results into ChatGPT. So what they do with their data, I don't know, but the fact is we don't know, right? So maybe they're using it to train, maybe they're selling it, maybe they're not doing anything with it. We just don't know. And so we probably don't want to be putting it into ChatGPT directly. So this is the point where most people kind of abandon their projects. They've done something cool with Game of Thrones. They've shown it works. They have a use case, right? Maybe they got over that first hurdle and they understand the use case of this, but they get blocked here because all the tutorials they've watched, all the blogs they've read, all show it using the public API keys from OpenAI. And you can't really use that in a real life setting, at least if you care about your data. Maybe you're using publicly facing data and you don't care. But for a lot of these types of situations, internal databases and whatnot, you don't want to be sharing that data. So what do we do about that? How do we avoid sending data to ChatGPT? Well, there's a couple options, but most of it always comes down to you need to stand up your own custom LLM. That's what we did at Microchip. We've been able to stand up and deploy our own custom LLM. and we use that internally. Now, there's a few ways and options you can do that, right? If you want to use open source LLM like the new Llama 3 model that just came out, they actually have native support with LangChain. So you can stand that up on a server or on a cloud tenant, and you can connect that directly to LangChain, and you're good to go. But if you want to use something a little more niche, or you want to train your own model and use that with LangChain, well, you can do that too. And you can do that through custom LLM wrappers, which is what the documentation I'm showing you here. And what this allows you to do is you can take your custom LLM and you can wrap it up into a LangChain class and make it an LLM object within LangChain that can be called and used in all the different types of chains and function that LangChain offers. And this is actually the first version that we did, right? We created a custom LLM wrapper. I'd like to show you the code, but I can't share that with you. But this is just the top part of the documentation. If you go look this up, it has all the boilerplate code for you. It has examples of how to run it. And again, this is kind of the last resort if you're not using one of the LLMs that has native support, or if you're not using the public API keys. But you might be saying, hey, William, are you telling me I can't use GPT-4, right? I can't use ChatGPT, the best LLM, in these use cases? And the answer is kind of yes and no. If you don't want to use the public API key, there's not a lot of options to get access to a private instance of ChatGPT. But there is one way, and that's through Azure, so Microsoft's cloud tenant. If you have an Azure tenant or an Azure subscription, they do offer you to be able to create a resource, an Azure OpenAI resource, where you can deploy a private instance of ChatGPT on your private cloud tenant. The caveats there are you're paying by the token, and these kind of RAG models can rack up a lot of tokens because you're sending multiple LLM queries per question. And then also it's not 100% publicly available. You have to go apply for access for it. But if you're gung-ho on using ChatGPT, there is a way to get private access to it. Okay, so at this point, we have our custom Microchip LLM. So we no longer have that blockade of not being able to pass our data into it, right? We have our use case and we know what we want to do with it. So we're done, right? We fixed it, we solved all our problems, and everything works. Well, that's kind of what we thought too. And at this point is when we actually presented internally and said, hey, look at this cool thing we built. It's really useful. And the big problem that came out of that is it was really popular. So the problem is we were working in a bubble, and we didn't really think about what this would look like if other teams wanted to do the same thing. And the problem there is that this chain is a unitasker. And what I mean by that is it can only do one thing. It can only do one thing. It can only answer questions on this specific Memgraph database. If you try to ask it a generic question that any LLM could answer, like, hey, why is the sky blue? It's going to try to take why is the sky blue and translate it into a cipher statement and push it through your Memgraph database, right? It doesn't understand that it doesn't need to run this chain. It just runs this chain every single time. So now all of a sudden you have all this interest, and you have the workspace interface, and the quality team wants its own chain, and the manufacturing team wants its own chain, and HR and planning and finance and et cetera, et cetera. And you've got all these different chains that can only do a single thing. And you have to have a separate interface for every single one of them. And if you just want a general chatbot, you stood up this LLM, you did all that work to get a private LLM. If you just want a general chatbot, you have to have a separate interface for that too, right? So now you're just replacing one problem with another. Instead of the problem being, hey, I'm having to wait on people to get answers, or I don't know who to go to to get the information I need, you've replaced that problem with, I don't know what interface to go to. I have this question, but which interface do I go to and ask this question of, right? And it can get tricky because there's overlap here, like quality and manufacturing. If you have a question of, what was the yield on this job, this manufacturing job? What was the yield? Well, is that a quality question or is that a manufacturing question? And your best bet is just to pick an interface, and hopefully you get it right. And you get the answer you need But otherwise, then you have to go check another manufacturing one. And even in manufacturing, that could be split out, right? There's different fabs we have. They collect different data. They have different data sources and databases. So even all of that could be spread out, into much finer detail than what I'm showing right here. So how do you deal with that? How do you deal with the fact that now this just doesn't scale because each chain can only do one thing? Well, if you start to look at these chains, there's really one common denominator, and that's that you have a user asking a question. So what if we could actually separate the chain from the user and the question and pause for a moment after the question's asked? You pause and you say, hey, which chain should I use? Well, that's exactly what we can do. So if we kind of, separate these, and we now call the chain, the part of it that just executes, not the question, but it just executes the chain, we start calling that a tool. Well, we can put all of that in a toolbox, and we can put an LLM, another chain basically, between the user and the question and the toolbox. And so that LLM, that agent, what we're calling it, can actually make decisions on what tool to use. So you have a user now, and he asks the question just like they normally would. And then the agent goes through and it decides if it needs to use a tool. There's a chain it kicks off. This is all abstracted away, but there's a chain it kicks off and it decides, hey, do I need to use a tool? And maybe the answer is no. Maybe you're just asking why the sky is blue. And it can answer that without using any of the custom tools. And so it can go do that. And it acts just like a normal chatbot. But maybe it does need to use a tool. And if it needs to use a tool, then it needs to decide, well, which tool should I use? And it uses your question as well as a description of each tool to decide which one is the best tool for the job. And once it decides which tool is best for the job, then it kicks off that chain and then passes that information to the user. So ultimately, what you're left with is you have a single interface for all the different databases, all the different tools and chains that you have. You have a single interface that the user can go to and just ask a question. You don't have to select a tool. You don't have to select a database beforehand. You just ask the question and the agent will do the rest and orchestrate everything for you. Now, the really cool thing about agents, though, is not just all the language tasks it can do, right? And these RAG methods. You can actually build tools to go interact with the world. So what I mean by that is the way you convert a chain to a tool is by wrapping the chain up in a Python function. And you put a little decorator on top. But basically, anything you could write a Python function to do, you could give the agent access to do. And if you're familiar with Python, this general purpose programming language, that's pretty much anything, right? You can do anything with Python. And so for our case, for this demo and for this use case, we actually built an email tool that allows our agent to go interact with other people within our organization and email out the information that we've had in our chat. So this database and these queries and these conversations we're having with our agent is no longer contained to just the chat window. We can actually have it go interact with other people. So what does that look like? Now our interface looks like this. We have agent chip because it's no longer just the workspace database. And we can ask similar questions, the same questions we've asked before, like why was this sales order late? Tell me more about the sales order. And we're getting the same type of information that we've got in the past. But then once we've gotten all the information we want, maybe we want to send that off to someone. But instead of copying and pasting it and putting it into an email ourselves, we can actually just ask the agent to do it for us. So we can say something like, hey, email this information to William Firth. And it'll go through and it'll find that email tool and it'll kick off that chain, or it's not a chain, but it'll kick off that function and it'll populate all the inputs to that function and it'll send that email and it'll look something like this, right? It knows it needs a subject. It knows it needs a recipient. It knows it needs a body and the body should be formatted in a certain way. So doing nothing more than having a conversation with the agent, I can then go summarize this information and get it out into the world. And we're not just contained into our chat window. So agents are a whole rabbit hole you can go down, but as you can probably tell, I'm very excited about them and we plan on using them very extensively here at Microchip. So what are our lessons learned? So relatively, connecting an LLM to a graph database and building the chain and agent, that's the really easy part, right? There's tons of tutorials out there. I'll link to some some that I found beneficial to myself when I was doing this. There's a lot of information on how to do this out on the web. YouTube videos, tutorials, classes, you can do it. But they're always going to be doing it with the OpenAI's API keys and sample databases. So the way to really make this a real product is by standing up the private LLM. And that's the really hard part about all of this. If you can do that, you're going to be worlds ahead of other companies, and you're going to be able to build all these really cool tools and get through your RAG models with your graph database. Third, this solution, again, is not for the seasoned Cypher developers, right? It's for providing those end users, those business decision makers that either don't have access to the data or don't have the technical training to access the data they consume. It's getting them closer to it, right? And it's especially true when you talk about graph databases, because not a lot of people know Cypher, right? A lot of people know SQL, but Cypher is much more niche, right? It's growing in popularity, but right now it's much more niche. So expecting people to know that is difficult. And there's always going to be that technical hurdle. And if we can bypass that directly or completely, then you're going to be in a really good place. And then finally, again, agents, they're very powerful and they're flexible tools. And there's a whole rabbit hole you can go down them. They can use multiple tools in the same query that you send. You can have multiple agents interacting with each other for checks and balances. There's a whole world of agents that I invite you to go start researching because it's very interesting stuff. A few quick takes I wanted to talk about that didn't really make it into the presentation, but I find are very, very important that I want to just touch on. So how intuitive your schema is directly affects your performance. What I mean by that is if you're using terminology and acronyms that are not easy to follow in your schema, when you're naming your nodes, you're naming your edges, you're naming your attributes, if those aren't intuitive, your LLM's going to have a hard time making those connections. But if you're using the same verbiage, if you're using natural language to name these things, your LLM's going to have a lot easier way of getting you the right answer and the right query. An example of that in my case is, you might have noticed I kept using the term work plan, right? I said, are there any work plans in place to improve the ship date? I didn't say, are there any efforts in place or is anything happening to improve? I specifically use the term work plan. And that's because I know in our schema that we use the term work plan. So that I'm kind of nudging the LLM to give it a little bit easier of a time making those connections and getting the right query. Similarly, how large your schema is going to directly affect your performance as well. If you have a huge schema, and again, not necessarily a huge database, but a huge schema, and you have a lot of different types of nodes and a lot of different edges and a lot of different attributes, if you have a huge schema, it's going to be really hard for your LLM to make the connections without making a wrong turn somewhere when it's traversing that graph. So you end up having, a little bit less performance in that case. Okay, second, the boilerplate prompts work really well, but there's a lot of room for improvement. So in LangChain's documentation, when you're looking at the Graph Cypher QA chain, it's going to have some boilerplate prompts for converting to Cypher and summarizing the data. And they work well out of the box, but there's always room for improvement. I said agents are a rabbit hole, but prompt engineering is a rabbit hole as well. And I have some links for that as well if you're interested in diving deeper. But I wouldn't focus too much on the prompts at first. Getting the agent stood up, getting your private LLM stood up, that's the important part. And then you can kind of fine tune with the prompts. And then finally, or a couple more things, sorry. So you might be thinking that this whole text to Cypher, this whole chain RAG model that we're doing is really slow. And why don't you fine tune a model with the same information? It would run a lot faster. But the benefit of using this RAG model is you have real-time access to the data, right? You're as up to date as your database is. So it takes a little longer. It's true. It takes a little longer to make those queries, but you always have the most up-to-date information on demand. But if you're fine-tuning a model, the moment you're finished retraining, your information starts becoming obsolete. And that's really important when you're in a place in a industry like manufacturing and there's updates constantly being made. You need that real-time data. You also don't have the issues of having to have a retraining flow and a deploying flow. So a lot of the ML ops part of deploying and retraining, you don't have to deal with, right? You just have a model, you never have to update it. Unless you want to, and because all it's doing is really running prompts and converting from text to cipher. And then finally, the last thing, it's last but definitely not least, is security consideration. So your LLM has access to your database and there's no human in the loop. And what I mean by that is it converts that question, why is the sales order late? It converts that to a cipher query and then runs it immediately. It doesn't stop and check and ask you for permission to run that query. So if you had a bad actor in your organization, it's possible they could write a prompt and send it to your chain that would get it to write a query that would, match n, detach, delete n, right? It would just delete the whole database. So you have to be really careful about the like controls you put around the database and what access you give the LLM. You want to make sure it has a read-only access and that it doesn't have write access, because you might be able to notice that it detached and deleted everything, but you might not notice if it uses a merge statement instead of a match statement, right? And a merge statement will, if that information doesn't exist, it'll create it. So now you're just adding false records to your database. So you want to be very cognizant of that, and you want to be careful with who you give access to and who you let develop, as well as what kind of access you're giving your LLM to your databases. Okay, finally, I just want to run through these resources because I think they're very useful. So that top one is the LangChain custom LLM wrapper documentation. So if you want to look at that, I think it's well worth it. There's a link to a previous community call with Brett Brewer in Memgraph. And that's where I really started working on this project, because I watched that call and he went through the whole Game of Thrones, how he did it with LangChain. And it's a lot more in depth from a code's perspective. Now that video is aging a little bit. It's getting a little old, and LangChain deprecates stuff really quickly and is innovating a lot. So it might not be exact, but it's a good place to start if you want to understand a little bit more about this flow that I've been showing in this graphic. The next two are blog posts by a guy named Tomasz Bratonek. And if you know who he is the pioneer in this space, right? If you talk about LLMs and you talk about graphs together, his name will come up. He is the pioneer in this space. Everything I've done is basically from reading his blogs and then just implementing what he's developed into a real business case. He's the one that wrote and contributed the Graph Cipher QA chain to LangChain itself. So he's one to follow. These two specific blog posts, again, they're kind of aging at this point, but they're still worth a read. But these go over specifically what I've kind of shown implemented here, and are well worth the read, and following him is well worth it. And then finally, there's a prompt engineering guide, which is a website that just goes in depth into all the different types of prompt engineering and tips and different ways you can engineer that to get the best out of your LLM. Okay, that's all I got. So I can pass it back off to Maya for questions. Thank you, everybody.
Thank you. Thank you, William. Let me just quickly share my screen. And that was a great presentation. I especially like the tips and tricks session, William, because that I think is super helpful for anyone out there who's trying to implement this in a real world in a real world test in a real world situation, right? I mean, you can tell I use the Game of Thrones. I'm sad you poked fun at it.
I'm sorry.
No. But what you presented was just really, really important, and I really appreciate that. It's time for Q&A, but before we do that, I'd like to remind the audience to take the second poll right now before we dive into this Q&A session. And the question there is, are you utilizing LLMs and Graph together today? All right, Q&A. Are you ready, William and Zhao? The first question I see here is, have you seen failures or hallucinations in the agent's responses? And if you had to give a percentage, what value would it be? I think maybe, William, this is a question for you.
Yeah, so I don't know if I can give you a percentage. We don't see so much of hallucinations, at least in the end result, because what we're generating is a cipher query. And so either that query is going to run or it's not going to run, or it's going to give you the right information or it's not. So what we really tend to see is we get the cipher query generation wrong, or it leaves off part of the question, right? If I'm asking, why is this sales order late? It might just forget the late part of it and give me general information about the sales order. And so it's not necessarily hallucinating, or it might be hallucinating in that it's not, interpreting the whole question, but we're not really seeing like it provide us with totally wrong information. It's more that it gets the query wrong, and then, obviously the answer is wrong at that point.
Yeah, that definitely makes sense. We have a ton of questions, so let me try and go through these. The second question is, how have you navigated the challenges of crafting your graph model and ensuring the LLM comprehends it effectively? Were there specific, let me just finish off. Were there specific obstacles related to the precision of edge and node typologies and naming conventions?
Yeah, so that's kind of what I talked about at the end, right? Like that intuitiveness of the graph is really important. Now, you might be trying to apply this method to an existing graph database. So you haven't necessarily had to worry about that intuitiveness of the naming conventions, but that is so important. So my advice is, if you're creating something new now, to really pay attention to that, to really pay attention to the verbiage you're using in the naming convention, and make sure you're using the same kind of terminology that the end users are going to be using when they're asking questions, like, the workspace example. There's plenty of others of that. But if you're using like acronyms for your node names, that's going to be really hard for the LLM to make those connections, except, right, that can be kind of band-aided if you in the prompts, right? So you can give definitions of some acronyms in the prompts beforehand, before it generates a cipher query, which can help make those connections as well. So that's one way you can help. You can also give like question answer pairs. If it's really struggling with a certain type of question, it's just not getting it quite right, you can go into that initial prompt and say, here's some example queries, and you type the question and you can type out the cipher query you're expecting, and you can give those question answer pairs so that it can kind of understand better what you're trying to generate.
Yeah, that makes a lot of sense, for sure. The next question is, I was wondering how you handle it if the graph schema exceeds the content, maximum token of the model.
I haven't run into that issue where the graph schema is so big it maxes out the token limit. If that's the case, I feel like your schema is probably too big. And in which case I would trying to crop your schema. So I don't think there are any like, native tools to do this, but you don't necessarily have to pass your entire schema into the prompt. If you have specific questions you're trying to answer for a specific tool, you can just send over like, hey, only use these certain nodes and these relationships to craft your cipher query. You don't have to send the entire schema. And if your schema is so big and you want to be able to answer questions on the entire thing, you could break your schema out into different tools and then, describe that schema in the definition or the description of the tool. And so then it can choose which schema it's going to run its chain against. That would be my recommendation. We haven't really had to deal with that though, but that's the first thing I would do to approach that problem.
A great recommendation for sure. The next question is, and I'm trying to get through these questions as quickly as possible. How do you train an agent to decide which tool from the tool chain to use?
So we didn't really go into like the agent prompts, but they have their own set of prompts. Really what it's running are, chains itself to do this decision making. So you can go in and tweak those prompts, but what it's really looking at is the question that you're asking and how well that relates to the description of the tool. So when you create you define the function, when you define a function in Python, underneath it, you can put a docstring and you can describe what that function does. That docstring is what the agent is looking at to compare the question and the tool and match them up to try to get the best tool. So
Perfect.
having a very descriptive description is good.
Cool. We have time for 2 more questions, I think. So I think this one's for Xiao. How do you evaluate your pipeline? Do you have issues, and how do you resolve them?
Yeah, I can answer this question. So how to evaluate our pipeline is always a big problem. So normally we kind of manually generate some like problems and their answers. And once we put our RAG into our productions, we can like gather more like input and the response from our colleagues, and then we can have like more and more data for us to build our evaluation data set. And after that, we can design our metric like F1 score or correctness or even similarities to see how we can make our prompt become better.
Thank you. I'm going to do this one last question. Do you have an example of a prompt that passes in part of a schema?
It passes in part of, you're saying like a subset of the entire schema?
Yeah, that's what I understand that question to be.
Yeah. So, and like I said, we don't have an example. We don't have a database big enough that we've had to do that. The problem is, when you're using the functions or the tools to pull the schema, it pulls the entire schema, right? So you would probably have to take that schema and do some manipulation in Python to cut out the parts of it you don't want and to kind of crop it. And then you pass that in like you would pass any variable into a prompt. So every prompt, when you pre-write those prompts that go in where you pass the schema into, it's pulling a new schema every time you ask a question. So it's live and up to date. So you would just need to build a little pipeline that when you pull that schema, it runs through a few lines of code to crop that how you want it, and then passes it into the prompt for the LLM. Yeah.
Wow, it's a very time-consuming process. That you have to keep repeating this all the time. All right, we've come to the end of our webinar. I want to thank our guests, William Firth and Xiao, for this very, very informative webinar. I'd also like to thank you, the audience, for sharing this hour with us. I hope you learned a lot. But don't stop here. I know a lot of you had questions. Join our Discord to continue this conversation. We're always ready to answer your questions. And I just want to point out that we will take these questions and we'll try and respond to you one-on-one after this webinar. All right. A quick reminder to join us for our next webinar on May 8th, 2024, where Martin Vo, CTO of PaySure Solutions, will talk about real-time payment authorizations using Memgraph. And with that, I'll say till next time, ciao.